4.5, graphs of sine and cosine functions. What we should learn? We should learn how to graph basic sine and cosine functions, how to use amplitude and period to adjust our graph, how to graph translations, moving it up, down, left, right, and then how to do real life problems. So first, let's talk about what a sine function looks like by doing a basic graph, right? Starting off. So here's my little table. Here's the quadrantal angles just to make it easier. We're just going to use the unit circle to find the values. Remember, when you use a unit circle, it's like an XY chart, so we're just going to use the points, especially if we fall on the quadrantal angles, the ones on the axes. We're just going to use these points right here. Remember, if we're doing sine, well, let's just plug in the first one, right? So sine of 0. So you go here to 0, and it's a point. It's one of these 2 points. Which one is sine? Sine. Sine is the y value. So we're just going to use the y value on all these. And at 0, we get 0. So that's our first point. And then at sine of pi over 2 right here, and we're just using the y value because we're going up the unit circle basically. We're going to get the point of 1. So at pi over 2, we're going to go at 1. Like that. Then we're going to go down to pi. Sine of pi is just the y value, so we're back to 0. So right here, and then we connect this like that. Sine of 3 pi over 2. We go down to 3 pi over 2. We're at negative 1. Right there. Like that. And then sine of 2 pi, we went back up the circle. We get 0 again. And that's our sine graph. It looks like a little wave. And the cool thing about this is that it keeps on repeating. If I went to another point, if I went to like 5 pi over 2, you just go back up here, you're back on the circle. It's always been the exact same points. So this graph goes on forever and ever in both directions. Keep on doing that sine wave. So that's what a sine graph looks like. And we're going to quickly do the same thing with cosine. So come on, points back again. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Let's make this one, let's make it a little nicer to look at. Okay, like that. So we're going to do the same thing with cosine. Cosine is 0. Now cosine is the x value. Right, sine e, sine is y, cosine must be x. So at 0, we're at 1 actually. We're starting up here. Pi over 2, if we go up this graph, we're going to be at 0. So we're kind of coming down. And then at pi, we come down here. Remember the x value, so negative 1. So pi is negative 1. So it looks like this. Then we go down to 3 pi over 2. So we're at 0. And then finally go back up to a completer circle at 1. So like that. And we get a cosine graph. Now here's the thing, just like sine, right? If you keep on going, you're gonna keep on going around that circle. It's gonna be the exact same picture over and over again. So forever. If you look at these two graphs together, they're actually the same graph. A sine graph just starts in the middle and then goes up and comes back down. A cosine graph starts at the top of the amplitude, top of the little curve right there, and comes down and comes back up again. Like if you look at this part right here, right, that's just a sine graph. It's right there. So they're like the same picture, just starting at different locations. But that's a basic sine and cosine graph. So you can see here, right, and then it goes through all this stuff, like the domain and range. They go on forever, repeating the exact same picture, negative infinity to positive infinity for domain. The range is super important, right? We're doing a unit circle. All we ever get to is 1 and negative 1 is a max. So if you look at the range, it's always negative 1, positive 1. The period, we'll talk more about this in a second, but the period is how long it takes to repeat. How long to repeat. Right, remember these are the same pictures over and over again. So like right here, like this is my sine graph. After that, it starts repeating itself. So we call that a period. How long does it take to repeat itself? So from here to here is our period. X-intercepts, they keep on happening over and over again, so that's why it's n pi. Y function, the y-intercept's at 0. It is an odd function, right? You can see here, it repeats itself like that. And then origin symmetry. Over here, same idea. It's an even function, this one, because you cut it in half. This one you can't cut in half, but this one you can. So let's talk about amplitude and period. I talked about period a little bit over there. In our graphs, let me go up here. Amplitude is how high it gets. So from here to here is the amplitude. So like in our basic graphs we just did, our amplitude was 1. That's how high we went. And it's sitting up here, right? Amplitude is 1. And we're talking about why that happened, how we know that from the graph. So the amplitude is a number in front of the sine cosine picture. And it's always positive. This is telling us how far we are from the center of the graph to the highest point or to the lowest point. So like over here, our amplitude, notice they don't have 1, so it's 1, even though it doesn't show you. And 1. And that's all it's saying. It's like, how is it from the middle of the graph to the top of the graph? How much is that? That's the amplitude. Next is period. Period is about how long it takes to repeat itself, like I talked about over there. But there's a formula for it. So period has to do with the number next to your x, the coefficient of the x term. We consider that b, and the generic period is 2 pi. So if we want to find the period for any function, any sine or cosine function, it's 2 pi over b. Let's go back and check that with our original graph. So like on the first graph, our period's from here to here. That's how long it took to repeat itself. Right? It went down and back up to here again. Then it starts repeating. Now it's 2 pi. If you look at our equation, we didn't have a b. So our b here was 1. So our period was 2 pi over 1. 2 pi over b, which is 2 pi over 1. So just 2 pi. That's how long it took to repeat itself. Same thing over here. No b. So our period was 2 pi over 1. So 2 pi. And again, it takes a whole 2 pi to repeat itself. So that's period and that's amplitude. And those are the basics we need to know to graph a sine or cosine function. So let's do an example real quick. So we're going to sketch a graph of 2 sine x by hand. We're going to do it from negative pi to 4 pi. So I made a little grid from negative pi to 4 pi. Let's go 1, 2, and 1, 2. The two things you generally want to find are the amplitude and the period. So my amplitude here is 2. And my period is 2 pi over b. I have no b, so it's just 1. So 2 pi over 1, so 2 pi. We need that, and we also need, what's the basic sine graph? So when we do this in my head, a basic sine graph starts in the origin. It ends at the end of its period at the origin. You always start and end at the same spot for a period. That's when it repeats itself. Halfway between is where it crosses. And in between these two, halfway is my amp. And in between the last two, halfway is my low part of my amp. So that's a basic sine function. And again, it does repeat itself both directions. So we're going to do a sine graph. That's a basic sine graph. So over here, I'm going to start at 0. My period is 2 pi, so that's my next endpoint right here. That means halfway is pi. My amplitude is 2, so I'm going to go all the way up to 2. That's going to go up halfway between these two is my highest point. I'm just going to estimate it. Halfway between these two is my lowest point. Like that. And that is our sine function. Again, it looks a little funky because I did this by hand. But it does want to graph it all the way to 4 pi. So I got to go one more rotation over here. So we're just going to do the exact same thing again. I started here. I would end 2 pi later. Okay, that's my period. So where's 2 pi in that? Right, 4 pi. Halfway is where I cross. In between these two is my highest point. In between these two is my lowest point. So this is another rotation. And I also got to go back a bit. So you start here, right? Our period is 2 pi, so I'm going to go back 2 pi. I actually need to go back to here. That's where our point would be. Halfway between is my other point, right there. Now, if I started here, right, we go left to right. So if I started here, halfway between these two would be my highest point. And halfway between these two would be my lowest point. But I only care about this part from here on. So I'm just going to continue this part on. And there's my sine graph from negative pi to 4 pi. So we're going to do these real quickly with different, so let's talk about how to do a cosine graph. So everything's going to be the same, we're going to do this faster. We have amp, and we have period. When you do a cosine graph starts on top, starts at the amplitude. And then you always end at the same spot. So wherever the period ends, that's your other spot. Halfway between is the lowest point, the low amp. And halfway between these two is where you cross. And halfway between these two is where you cross. So that gets you a cosine graph before it starts repeating itself. So let's do these on the same graph. I'll do one in green real quick. So for that one, the amp is 1/2, and my period is 2 pi. Because 2 pi over b, but the b is 1. So 2 pi. So we'll start with the cosine. I'm going to start at 1/2. There is my amp. And then we have to end, right? We end at 2 pi. So we have to go to this next point. I always start at the amp, end at the amp. 2 pi, so period. Halfway would be my low amp. So halfway is right here. That's my low amp. So negative 2 pi, negative 1/2. And then halfway between these two is right across. So we have pi over 2. Halfway between these two is right across. 3 pi over 2. And there's our tiny our tiny 1/2 cosine graph. So you can see what the amplitude does, right? To really isolates how high and low the cosine graph goes. The next one, 3 cosine, right? My amp here is 3, and my period here is also 2 pi. So we're gonna start at the amp. 1, 2, 3. We'll also end at the amp. Halfway is the lowest amp, the amp on the low end. So down here, negative 3. Halfway between these two is right across, so it'll be right there. Halfway between these two is right across, which is right there. And I get something that looks like this. So you can see what the amp does to the graph, right? It really fixes how high and low it goes. Okay, so we talked about period. Next, let's talk about what the period does. Let's do an example of the period. So this one, we're going to do the same thing. Let's make this one just so it's a little easier to see. We'll go by halves here. My amp here is 1. My period is 2 pi over b. So my b in this case is 1/2. So 2 pi over 1/2, which gets me, when anytime you have like a fraction divided by a fraction, it looks scary. I just think about this as a divide sign. So I rewrite it 2 pi divided by 1/2. And the way you divide is multiply by reciprocal. So it's 2 pi times 2 over 1. So 4 pi. That's my period, 4 pi. Which means on this graph, let me fix it a bit. Make that 4 pi. I wish I had it nicer than that, but that's what we got to work with. So we're going to 0, pi, 2 pi, 3 pi, 4 pi. Okay, so for graphing this one, right? It's a sine graph. Remember, sine graph starts at the origin, ends at the origin, and halfway. Looks like that. So we're going to start at 0. We're going to end at 4 pi. Halfway would be 2 pi. Halfway between these two is my amp, which is 1. Halfway between these two is my amp, which is negative 1. And there we go. So it looks something like that. Again, it's kind of hard because I just redid this graph, but it goes much further than our normal graph, right? Normal graph would end at 2 pi. So normal graph we did would end at 2 pi. This one goes like double the distance. But that's how you do period. It's about translations. It's like in all our parent functions, anything on the inside moves it left and right. So it's a shift left or right. But in trig, we call that a phase shift. And all we're going to do is kind of do like we always do. Now we'll have a new start point, which is the phase shift, which is wherever our graph is. Like let's say we start right here, that's our phase shift. That's where we're going to start. And then you have to figure out where you end. Well, the ending point is just, you have the period, wherever the period is. So you go plus the period, which is normal 2 pi over b. Now get to your endpoint. So that's the idea. If you start with our phase shift, that lets us know where we should start at. And then you just add the period, because that's going to be 1 rotation. Now get your new endpoint. That's how phase shift works. So this is an example right here. So in this graph, we're going to find all the basics. We're going to find the amp, the period, and in this case, we have a phase shift. All right, so our amp, the number front, 1/2. So as high we're going to go, so 1/2. Let's put that in. So I'm going to put this little dotted line that's only for us. It's not part of the graph, right? So we know how high we could go and how low we could go. So again, it's not part of the graph, that's just for us. Our period. Now our b is the number in front of the x. So in this case, we don't have one. It could be here or it could be here. Like it depends on where they put it. So it could be, they could have factored it out and put it in front of a sign, or they could back of a sign, or they could leave it in the x right there. So in this case, we don't have one. Our period is going to be 2 pi over 1. Our b is 1 still. So just 2 pi. Notice it's going to take like 2 pi to finish our rotation. Our phase shift is this guy. Remember, inside opposites, we're going to move it right pi over 3. So we're going to start at pi over 3. And much like before, let me do this in red. This is just for us, so we know where we start. We start at pi over 3. This is our starting point. So let's start pi over 3. If we want to know where our graph ends, we're going to have to add the period. So go plus the period, which in this case is 2 pi. And that gives our endpoint. Well, the end of one rotation, right? Of one period of the graph. So common denominator over 1. So let's look at 3 times 3. So I get 6 pi here. 6 pi plus pi is 7 pi over 3. So we're going to end at 7 pi over 3 right here. So we're end. So we do that again. Again, these little dots are just for us, so we know what our graph looks like. So this box here is where our graph, our main part of the graph is going to be, the one we're going to draw. So we're going to start, it's a sine graph, so we'll start at the origin. We're going to go up and go down in this little box here. And then we can remember, the graph goes on forever. We have to fill up this whole grid, so we're going to go backwards. Same idea. Okay, let's get started. It is a sine graph, so we're going to start at the origin. Oops, look at me messing up. Right, we're shifting it to pi over 3, so we're going to start right here. We're going to end at the origin, so right there, that point right there. Halfway, now you could figure out halfway as we always do, add them up and divide by 2, but most of the time you can just eyeball it. 4 pi over 3 works. And that's about halfway. If you're not sure, you can always find halfway by adding them up. So pi over 3 plus 7 pi over 3 is 8 pi over 3. Divide that by 2, so times by 1/2. And you get 4 pi over 3. Right? That always works, but most of the time you just eyeball it. Halfway between these two is my lowest point, or my highest point, sorry, which would be like right here. So there we go. Halfway between these two is my lowest point of the amplitude, right there. And then we can connect our graph. And again, it goes on forever. And we're going to do the same thing backwards. Now, it's a sketch, so I'm not going to go too crazy about this. So like from here to here, negative 4 pi will probably be around there. So because it's just a sketch, I'm not going to go crazy about it. So something like that. So that's how I do horizontal translation, right? So inside opposite, it moves it right or left, and then that wherever it moves, that's your starting point. Add the period to it, whatever the period happens to be, and that'll get you your endpoint. Let's do another one. So in this one, I have, well, let's write this up. A couple things are going on here. So we have an amp. Amp is not -3. Amp is always positive. Amp is just a distance, so it's 3. The negative does have an effect. That would be a vertical shift. A vertical flip, sorry. Vertical flip. So it's an open upside down. So this is a cosine graph. Cosine graph normally looks like this. But if it's a negative cosine graph, we're going to flip it. So it's going to be upside down, like that. Right, so normal cosine graph looks like this. With the negative, we're going to flip it upside down. So that does have an effect, but it does not affect the amplitude. Amplitude still going up 3, down 3. Actually, let's do that, right? Amplitude still this. That's still our amplitude. Okay, our period is 2 pi over b. Now, what's our b in this case? Our b is 2 pi, but we should factor it out first because it's an affect or shift. You always have to factor it out if it's not already factored out for you. So this is going to be -3 cosine, pull out the 2 pi. Right, when you pull out the 2 pi, that's the number in front of the x. You just left with an x here. 4 pi divided by 2 pi is just going to be 2. So like that. So that's the proper way of having this equation. We should factor out that 2 pi. So it looks like this. So our period is 2 pi over 2 pi, which is 1. And now we have a phase shift. Right, inside opposite, it's going to be -2. So we're going to move it whole graph left 2. So our graph's going to start right here at -2. Now this is an easy one. We're starting at -2. And we add the period, which is 1. So period right there. We're going to get our endpoint of -1. I can do the math on that one. Don't need to do common denominator. So we're going to end right here. So that, in that little box right here, this little rectangle, that's made our whole graph of cosine. Right, because we're starting we're starting at -2 because of our phase shift. Our period's 1, so just, the whole graph ends 1 over, and our amplitude's 3 to -3. Now, keep in mind it is a negative in front, so it's going to be an upside down graph like I talked about. It's also a cosine graph. Remember, cosine graph starts at the amplitude. Normally we start right here, but we're going to start down here because it's negative. We always start in the same spot, so right there. Halfway between is our lowest, so all the way up here, halfway. We'll estimate. Remember the way cosine works? Halfway between these two is where we cross, so halfway between there is like this and like this. And this graph-ish, not my best graph, is our graph of this guy. And again, it goes on forever. So again, if you want to figure out, you can keep on going, right? It's just an easy period. So you go add 1 over. So this is where our graph's going to end right there. So same idea, halfway. Right, I should fill up this grid. So right there. And remember, these lines are only for us. They're not part of the graph. And I say that because eventually we're going to do cosecant and secant graphs, and they have lines, and tangent too. So for us, these are just like lines to help us graph it. That's all they're for. They're not part of the graph. Like again, I say that because tan, cotan, all the rest of them actually do have like asymptotes and stuff that you have to worry about, but not for sine, cosine. So this is just the graph. Okay, let's talk about a vertical translation. So vertical translation is, for me, the easiest one. This is our new middle. The new middle. If you notice when we do these graphs, there's always like the middle line, right? It's always in the x-axis. That's because it's always +0. There was no vertical shift before. Now there is. So that's just our new middle, also known as the printable axis. I always just call it the new middle though. So our new middle is going to be 2, and I'm just going to write it on the graph. So here's our new middle. And for me, this is going to be easier than the horizontal translation because we're going to do everything the same. What's our amp? Well, our amp is the number in front of the cosine, so 3. So that means, like it always means, right? You go up 3 and down 3 from your new middle, right? It used to be from 0, but now we're moving everything up 2. So this is my new middle. And we're going to go up 3, so up to 5. And we're going to go down 3, down to -1. Right? So this is the highest part of my amp, is 5, and the lowest part of my amp, -1, right? Because we're starting at 3, we're starting at 2, and we can go up 3 and down 3. My period, 2 pi over b. We actually have a b in this case. B is 2, so 2 pi over 2. So just pi. So again, we have no phase shift. We're going to start at 0, and we're going to go over to 2 pi, so to here. Right, we're starting at 0, go to 2 pi. Again, you don't need to do these things. I do it to help us see like what our graphics look like, right? Something like this. By the way, if we're going backwards, we'll go back 2 pi. So we'll set an n right here also. So like in this box is our primary graph. And that's pretty much it. Now we just got a graph. What are we doing? Cosine graph. So remember cosine. You always want to remember what the basic graph looks, right? Cosine starts at the amp, ends on the amp. Halfway is the lowest. Halfway between these two is where I cross. And that's our cosine graph. So we want to replicate that right here. So we're going to start at the amp. And at the amp, halfway, we can eyeball it, is pi. We don't need to eyeball it, it's right there. Pi. Halfway between those two is pi over 2. That's where we cross our new middle. And sending over here. And there we go. Should be more of a U, but you know, whatever. Alright, I'm going to do sending backwards, so I'm going to fill up this graph. Probably a little. Something like that. So there's how you graph cosine. So that's how I do a vertical translation. For me, that's the easiest one. It just changes your middle, and then from there you just base everything off of it. Okay, how about if we go backwards? On this graph, they want us to find the amplitude, the period, and the phase shift of the sine function. So this is a sine function. So basically, we're trying to do this. So we have a, it's a sine function, so sine b x minus c. And we want to figure out what a is, what b is, and what c is. So a, amplitude is probably the easiest one if you have an over grid. So it looks like to me, those are the marks. It's kind of hard to see. Oh, I'd say it goes up to -2. Goes to 2 and down to -2. So our amp, I wasn't say our amp is 2, right? Because it goes up to 2 and down to 2. But if you look at the graph, it's upside down, right? A normal sine function looks like this. This is going upside down. So I'm going to put a -2 up here for our a. Our amplitude is still 2, but there's like a vertical. So that's a. How about b? Well, b has to do with the period, right? So the period equals 2 pi over b. And that's the equation we got to solve. So we're trying to find out what b is. Well, all we got to do is figure out what the period is. Now this graph makes it a little tougher because we're going from negative pi over 2 to 3 pi over 2. The way you find the period is the way you find the period of anything. You just subtract where you end minus where you started. So 3 pi over 2 minus negative pi over 2, sorry. It's very important. Two negatives make a positive, so we get 3 pi over 2 plus pi over 2. So I just get 4 pi over 2, also known as 2 pi. So my period is 2 pi. Now all I gotta do here is solve the problem. Now this one's easy enough. You can just look at it and go, wait, those are equal graphs. B equals 1. Done. If you didn't, you can always cross multiply and get 2 pi b equals 2 pi, and then divide by 2 pi, and you get b equals 1. Right, that's how you normally would solve it. In this case, b was 1, so it made it really easy. Now the easiest one of all these is actually c. C should always be the easiest one. You're just looking at for where should the graph start. So there's actually lots of ways you can answer this. So for us, the graph is starting right here at negative pi over 2. So that's my c. Negative pi over 2. Right? That's where my graph's starting. It's right there. That's where my graph's starting. It's starting at negative pi over 2. So my whole equation will be this. Y equals negative 2 sine x plus pi over 2. Right? When you plug in a negative, double negative makes it a positive. That's why we move left. But honestly, that's only one answer. I just realized I could also done this way. Y equals 2 sine of x. If I did it this way with a positive sine graph, well, what does a positive sine graph start off? Right here. So it would be right there, this guy. Which I believe is just pi over 2. So I could also done it this way, where I do a positive amplitude, and then my starting point would be right here at pi over 2. So two equally good answers, unless they specifically said they wanted a positive amp, which they did not. So either one of these is fine. If you want to start right there, it makes it a negative sine graph, but you shifted left pi over 2. If you start right here in the middle, it's a positive sine graph, but you shifted right pi over 2. So it's a negative pi over 2. Okay, last one, we're going to do mathematical modeling, which is the same thing we just did, but now with the word problem. So we're going to do this one. So here's the time of, like, we're at a dock and the sea level is going up and down, starting at midnight. They want us to use a trig function model to model the data. Let t be the time with time equals 0, midnight. So this is 0, 2, 4, 6, 8, 10, and 12. So first thing we do is plot the data. So here's your thing. 0, 3.4. 2 is 8.7. Again, it's been estimates, it's plots. 3 is 11.7. No, 4 is 11.7. 6 is 9.1. 8 is 3.8. Again, this said like 10 is like almost 0. And then 12 is 1.2. So like that. So that's our data. So to me, this looks probably best like we could do a cosine graph if we start here. Or we could do like a sine graph that starts in here somewhere. So it kind of depends. Let's do a cosine graph. So if we're doing a cosine graph looks like this. Y equals cosine bx minus c plus d. Like that's our basic cosine graph, right? We're gonna have to find all these things: the amplitude, the period, the phase shift, and the middle. And I always start at the middle. So you want to find out what the middle of this graph is. So you look here. The middle is going to be like the max point minus the midpoint divided by 2. So the middle of anything, you take the max plus the min and divide by 2. So our max here is 11.3 plus the min 0.1. You get 11.4 divided by 2, which is going to be 5.7. So that's your middle. Around 5.7 is the middle of our graph. So 5.7. Then I do the amp. The amp is just from the middle to the highest point or lowest point. Either way, that's the amp. So to find the amp, we're just going to do the 11.3 minus the middle, which is 5.6. Okay, so only two more left. B, that's the period. So remember the way we find B is always the same. The period equals 2 pi over B. And then what's the period in this case? Well, it rotates every 12. So it goes from midnight to noon. So that's a 12-hour period. So this guy's just 12. So we gotta solve this. 12 equals 2 pi over b. Cross multiply. That is gonna be 2 pi. And that's gonna be 12b. Trying to solve for b, so divide by 12. And you get b equals 1 over 6, pi over 6. So that's our b. Last one. And now all that wouldn't change if it was sine. Like if we're doing sine, none of this changes. It's all the same, except for c. So c is, remember, where your graph should start. Because it's a shift. So where the graph should start. Right, so a cosine graph, that's the one we're doing. So start at the top, go down and back up. So if we're looking at this graph here, if I connect the dots, if it was a cosine graph, where should it start? I would say right here. Right, that's where the cosine graph would start at. So we're going to say 4 is our c. That's the only thing that changes if we did sine. If we did sine, we should start right here. We have to figure out what point that is. But since we're doing cosine, our graph would start right there. That's the only difference. So there's our equation. Y equals 5.6 cosine of pi over 6 x minus 4 plus 5.7. That's our model for this data here. And then the boat needs at least 10 feet of water to moor the dock. But we just got to figure out where 10 is. 10 should be right here. And for that, we have to figure out what these points are. And we're going to use a calculator to do that. So let's do that real quickly. So here's my calculator. I already typed in the first part. Now this part, I need pi over 6. So second pi divided by 6. And then I'll open parentheses, x minus 4. Close the double parentheses, right? The one I had 2 of them on there. Plus 5.7. And then over here we're going to put 10. Now a little trick, I already did the window because early on I did it by, I plotted the points so I could figure out what the window was. So that's why my window looks perfect, because earlier I plotted these points and I did stat window, so right there. So you might have to play with the window a little bit. Anyway, so I got to find those 2 points. So we're going to go second, calculate, intersect, and then we just want to get close to our intersection point. So there's one over here. You just got to get close to it. Hit enter a couple times. So first curve, and then it jumps to the second curve. Hit enter. And I get let's say 2.7. We'll estimate that. Then we're going to do the same thing for the other point. So second, calculator, intersect. We're going to go over here. And then hit enter a couple of times. And we get 5.3, we'll say. So, during what times? I'm going to say about from 2 a.m. to 5 a.m. So it's about those two. And that's the video.